I began by drawing a picture just because there's a lot of text in here, and I felt like with a picture I could start to organize my thoughts. So it's 1,200 gallons to fill up this truck, whatever it is. The water's coming out of the hose, it's at a constant rate, and the information I have is at 10 minutes, there's 65 gallons in there. At 15 minutes, there are 82 gallons in there. So I'm going to let X represent the time it takes to pump Y gallons of water. And then that allows me to organize the information and set it up as a rate. So I have time as X, water as gallons as Y, and I can use those two pairs, the 10 and the 65, the 15 and the 82, and that allows me to set up my rate. So I have 17/5. So that's a good start. So I know my rate of change now. Now that's a constant rate, and that lets me think about this as being linear, right? So because it's linear, I'm going to be able to use y equals mx plus b. Now I already found my rate. It's 17/5. Let's pop that in. And I can pick, I have two to choose from. I can use 10 minutes and 65 gallons or 15 minutes and 82 gallons. So for this one, looks like we did 65 gallons in 10 minutes. And when you solve that, you get 31. So your y-intercept, your starting amount, is 31. So now you have all of the information you need to create an equation. And so our equation is y equals 17/5 x plus 31. The question we're looking at right now is how long does it take to fill up the water truck? So filling up the water truck is taking that equation and setting it equal to 1,200. Why 1,200? Well, 1,200 is how much water the water truck can hold. So when we do that, we take that equation and we set it equal to, instead of y, we're going to have 1,200. That's how much the water truck holds. When we solve that, we get 343.8 approximately. And so it would take about 344 minutes, or if you want to think about it in terms of hours, because we don't really measure things like that in terms of minutes, that's going to be about 5.7 hours to fill up this whole water tank.